So there are a number of ways.
Okay.
I'll start with the more obscure and end with the more important.
Okay.
So one of the things that's obscure, actually, and important, they're all important, is the goal of the National Strategic Computing Initiative, which is to tie high-performance computing and data analytics. So one of the things that I see looking ahead is that we're going to be able to make government data available with high-performance computing for not only government uses, but the general public's uses, and that's going to require tools for access that don't exist today. So one of the key tools that we're going to be needing is the ability to do queries by natural language. A lot of the artificial intelligence advances that have been discussed here with machine learning will be the technology that makes that necessary. But that human interface, the ability to not have to figure out, not have to know anything about how the data is structured or where it is or what the relationships are, but to have the smarts be in the computer itself to understand, because it has done machine learning on how humans communicate, that new interface will be key to achieving the vision of that strategic computing initiative to leverage the power of high-performance computing with big data and data analytics. Another thing that's happening, the Internet of Things. I haven't heard that buzzword mentioned in this program yet.
We did a show on it just not long ago, and it went over big.
But the Internet of Things is a big generator of big data. As I said earlier, in NOAA anyway, everything we do begins with an observation. And how amazing would it be if instead of just having the networks that we have now for temperature gauges and rain and pressure, if the world were instrumented by the smartphones we carry? Scientists have already shown and documented the accuracy and resolution of the pressure sensors that sit in smartphones and tablets and how they mapped to the pressure changes that occurred when Hurricane Sandy hit the New York metropolitan area. Right? So imagine that big data. There may actually be more, I don't know the math, but there may be more mobile devices than there are people in our country.
I would think so.
And if you
I think my kids all have about 4.
Right. And you could just tap into that. If you could tap into that as a source of observation, imagine the resolutions, imagine what we can do for our forecasting ability and our science. When we think big data in NOAA, we typically think about it in terms of, well, I've got this model, I need to feed this model, and if I can get this additional data from this satellite, then I can feed the model, I can improve the resolution. And so it's a very deterministic thought process. Right. It's true that models are technically statistical experiments, but there's a lot of determinism. So, what we want to do is use the big data that we have in data analytics to not just improve our models, but look into the data and find out what questions aren't we asking. What can the data tell us about what questions we should be asking? Right. And that's something where we need to be doing a lot more.
Excellent.
And the last two things I want to mention are economic growth. We've already talked about that. And the use of new services to improve services at the local level, at the commercial level, and finally, improving our mission itself.
Right. Well, that's what it should be all about for everybody, right?
Right. I mean, and right now, if we can give you an extra 3 minutes, an extra 20 minutes for tornado warning, that saves lives.
Absolutely.
Big data can do that.
Absolutely.